I want to do a very complex chain rule example to show that you go layer by layer by layer. So the outside function here is the cosine squared. Well, it's actually just a square function actually. So do the exponent first. So it would be the derivative of this would be the 2 times the cosine of x cubed. Alright, well, our next layer here is the cosine. Times the cosine of x cubed prime, right? Next layer here is the cosine of x cubed. That's the next outside layer. Okay, so we now have 2 times the cosine of x cubed times derivative of cosine is negative sine x cubed. But now we have this inside function x cubed. We take derivative of that times x cubed prime. So we'll ask for 2 times the cosine of x cubed times negative sine of x cubed times the x. And so the x squared, right? So we put it all together, you should put this, we have negative of 6x squared times the cosine of x cubed times the sine of x cubed. So I mean, yeah. So what we did here, all we did was we'll call this the outside function. So yeah, I'll even label them all in different colors for you to see the 3 different functions here we had to differentiate the 3 layers. And this was the second layer, and then this here was the third. So this is the derivative of the first layer, derivative of the second layer, and then this is actually I messed up my colors. This should be the derivative of the second layer. It should be green, and then this is the derivative of the third layer, and you just went layer by layer by layer by layer. So eventually you should have yeah, just think of it as an onion. Exponents will always be your outside layer. Always that. If you have, as long as if it's not inside a function, then it will always. So if you have some function to exponent, then exponent is going to be the outside layer. And chain rule is something that takes practice, but when you get it, it's actually pretty easy. So don't let it discourage you. I say to keep practicing, but just always keep taking the derivative until you run out of layers. That's pretty much all it is to it. Alright, bye.